Welcome back to Coding and a Cup of Java, lecture number 5, Switch Statements and Methods. Well, the last part of this lecture we already covered switch statements, so we're already done with that, and we started with methods. We just introduced them a bit, checked what we could do with the most basic ones. We had some code that we could call and well, just basically run a piece of code by calling it from somewhere else. But like I've also said, this other part of the lecture is not going to be enough to discuss everything about methods, so the next lecture is going to talk about them as well. But let's get going, shall we? So I'm going to start with a new little example to show you about parameters, and I will show you exactly what those parameters are. So more methods, like so. And then we do the well, the main thingy, the public static void main, like that, because we need that one. And then I'm going to do, here we go, static void print welcome message. Okay, so just like before, we have static, we have void, more to that later, and then we have the name of the method. But then we had a pair of parentheses there, right? But you can actually add things in here. So we're going to add string name. So this is a parameter, and what it is that we well, it's the type string, and it's the name. So the parameter's name is name, and it is of its type string. So what we can see in the main method, apart from it having public here, and that's going to be a part of the next course, but we have static void here as well. We have a name which is called main, and then we have a parameter which is of the type string array, and it's called args. So yeah, so the parameters that we're having here, we can just use them like variables. So we can do system.out.println like so, and then we do hello. We want to say hello to that person. Nice to meet you. Like that. Okay. So what we can do now is when we use the name here like it would be a variable, it's a parameter which is working exactly the same. But what we now can do, or will have to do, when we call print welcome message, is that we have to give it the parameters we're looking for. So we're looking for one string parameter here called name. We don't care about what it's called when we're calling it. So what we want to do here is just give it one string parameter. So I'll do it with this parameter there, or the value John, and then I will do it, another call to it with Anna instead. So if I hit compile now, save it, and then run it all, you will see that it's going to say hello John, nice to meet you. Hello Anna, nice to meet you. So what's going on here is we start a program and we have the first method call here. We call the method called print welcome message and send along John as the first value. That value here, the value John, is going to be stored in name, and we can access that value from inside the method. We're using the parameter name when we print out the welcome message. So we print out hello, and then the user's name, and then nice to meet you. And then when we've done that, we go back, like always, to after the call. We call the method again, and this time we print the welcome message, but we send along Anna instead, and therefore the name here will get the value of Anna, and therefore it will say hello Anna, nice to meet you. So with the parameters we can send information into methods and do different things depending on the values of these methods. So I'm going to extend this example a bit, because I've said parameters, not a single parameter, so you can have multiple ones. So just a comma, and then you continue. So I'm going to have a variable called overExcited, and if overExcited, if that's true, then we want to do something. Otherwise, we want to print out the message we had before. So if we're overexcited, then we want to print out something else. So then we can do like hello there, and then the name. It's so very nice to finally meet meet you, it's an honor, something like that. So now, depending on if we're overexcited or not, we will print out different things. So we send along two things. We send along the name as the first parameter, and we send along the Boolean value overexcited as the second one. And then we basically just use these two values to do different things. However, now, if I hit compile, it's not going to work. The reason why it's not going to work is because, well, we have print welcome message here, and we have one string. The only print welcome message that exists has one string and one Boolean value. Therefore, we'll have to give it one string and one Boolean value, like this. So now I have a string, which is John, and then the Boolean value false, so that means that we're not overexcited. And then we have Anna here, and we are overexcited there. So if I hit compile now, it works, because it can match the values we send along with the parameters we are asking for. So you have to give the exact same combination that we have. We can't even do false John, so we can't mix them around. We have to have them in the correct order, so it knows which parameter gets which value. So now if hit run, it's going to say, hello, John, nice to meet you, because, well, apparently we're not overexcited to meet John, but, well, it's nice to meet him anyways. But for some reason we're overexcited to meet Anna, and therefore it's going to say, hello dear Anna, it's so very nice to finally meet you, it's an honor. So as you can see now, we send along two different values to the print welcome message method, and depending on these values we're going to print out different things. But this was just a small little example on how you can do this. So I'm going to make sort of a more proper example now, which is actually quite useful. It's something we've been missing throughout this course. Okay, here you go. So I want to use the scanner, and then I want to use, well, this program is going to be called valid integer example, like this. And what we will do is write a method that will give us a valid integer. You'll see in a bit. So first of all, I need the public static void main. It's a string array parameter called args. So as you can see, we learn more and more about what this main thing is. Now we know it's a method. We know we have a parameter here. We know that the brackets here means it's an array. What we don't know yet is what the void means and what these public static means. But we'll learn the void one in this lecture. The other ones will be the next course. Okay, so that's the main thing here. And then we want to have static void next valid integer. So this is a method I'm going to write, which allows us to get the next integer, but it's going to be a valid one. And how is it going to be a valid one? You'll see in a bit. Okay, so first of all, I want to have a scanner when I get a valid integer. I want to get it from the scanner, and we create a scanner up here, because here we can define what scanner we want to have, how we create it, and like always, we create it from the standard input there. And now if we want to get a valid integer, we can just do next valid integer and then send along my scanner, like this. I'm going to do it twice. As you can see now, I call it my scanner up here, I send it along, but here I call it scanner. And that's totally fine. We just send along a value which we happen to store as my scanner before, and then it's going to be named scanner inside the method. However, we could do my scanner here as well, even though we would now have two things that are called the same. They have the same name, but that's totally fine because they are in two different locations. So we can't reach the my scanner from inside here by typing my scanner. It's not going to work. The my scanner is defined inside this method, so we can't reach it inside another method. But of course we can send it along as a parameter, and therefore we can access it. And that's exactly what we're going to do. Okay, so we want the next integer, but we want it to be a valid one as well. Because usually if we ask the user for an integer and the user enters like hello or banana or I don't know, then we're going to crash, because hello or banana is not a integer at all, and therefore it's not going to know what's going on there. Okay, so how do we solve this? Well, we can do it like this. Has next end. And then we do scanner dot next. Okay, so what happens here? What we're doing is we're looping as long as the scanner does not have a integer as the next element. So when that's the case, what we do is simply go in here and read the next word. So if we find like banana, we're going to realize that that's not an integer, and therefore we're going to go in here and we're going to read that, so we get the banana and text banana there. And what will we do with it? Well, we won't do anything at all, but by using scanner.next we're also going to remove it from the buffer, and therefore we get the next part there, which might be another text, a piece of text, then we're going to remove it. Another piece of text we're going to remove it. And finally, if we find an integer, then this part here, not has integer, is going to be false, just because we do have an integer, and therefore we're going to exit out the while loop. And when that has happened, we can just grab the integer, like so. And now, all of a sudden, we know that we're going to get an integer. It's not going to crash just because we type something else. And now finally, yes, let's just print that out. The valid integer is integer method. There you go. Hit compile. Save that. And now we can run it. Remember, we're calling that method twice. Run. Okay. So now I can type hello. And just type a lot of things here. And it's not going to crash. It's just going to, well, get rid of them because they are not an integer. But if I all of a sudden type like 23 there, then it's going to say the valid integer is 23. But I'm still going to get this box here to type something else in. Well, why? I call it twice. So otherwise it will just end, but now it wants me to enter another valid integer, which I can do totally fine, and there you go, program stops. Sweet! What if we want to make sure that this integer is in a valid range? We might want to ask for, I don't know, how old are you, and then you might not want to be able to type in a negative age, like I'm -2 years. That doesn't really work. So I'm going to add 2 more parameters to give some more examples how you can use parameters. So we have an integer parameter called min for minimum, and we have an integer parameter called max for maximum. So we're going to check that this this integer that we get is actually in the valid range. How do we do this? Well, first of all, we can move this part here. We can declare the integer at the top, and instead of declaring it there, we just assign it the value. Why am I going to do this? Well, you'll see. There you go, now you've seen it. So what I'm going to do here is we're going to do the outer loop, the do while loop. We're going to loop that as long as the integer is less than the minimum value, so that means it's outside the range, or that it's greater than the maximum value. There you go, and then we can do something like that. So first of all, we declare the integer, and then we loop so long as the integer is less than the minimum value, or it's greater than the maximum, so that means it's not valid. But since it's a do while loop, we can go into this and get the first integer without a problem. We wouldn't be able to have a normal while loop here because, well, the integer hasn't been defined yet. We're doing that inside a loop the first time. So this is a very good example of when we can use a do while loop as well. So then we start to find the next integer, which we will store in integer. So integer will always contain the next integer. So if we type something else, it's not going to work. But then if we find out that that integer is not valid, then we will start again to find the next integer. And finally, when we actually have an integer that is in the valid range, we will print it all out. So let's compile and try that again. Oh, something happened. What happened? Well, we don't have any range here for it, so we need to give it all the parameters, remember? So if we have 3 parameters, where the first one is a scanner, the second one is an integer, and the third one is also an integer, then we need to give it a scanner, we need to give it an integer, and then an integer as well. And we can, just for completeness, we can print out to the user what we're actually looking for. Please, here we go. Please enter, well, an integer between 2 and 5, inclusive. There you go. So just for the user to see that, see what we're expecting from it, and then we do 10 and 50. So now, if we're running this, hit compile, and then hit run. There you go. Okay, please enter integer between 2 and 5. So if I type hello here now, it's just going to continue asking me for stuff. If I type 1, it's still going to ask me for stuff. If I type 3, it's going to say the valid integer is 3, and then it's going to continue in the main method here and ask for the second one. Here I can do the same thing. I can speak rapidly here, just random bullshit here, and then I can hit a 2 there. It's not going to help. I can type 10. It's going to be correct, because it's an integer and it's in the valid range that I'm defining with the 2 second parameters, parameter 2 and parameter 3. Right, awesome. Not really. It's not really that awesome. We're just printing out this integer. Didn't we want to get the integer? Because when we use scanner.nextInteger or scanner.nextInt, then we actually get it and can use it for something. Well, yeah, we can do things like that, and I will show you that in just a sec. But first of all, let's do it in another program. So I'm going to show these new things called, well, return types. We can return different types from the methods themselves. So I will show that in this example here, and then we'll go back and continue working on the valid integer example and expand it using these new things. Okay, so public class, so the name here of the program, return example. Okay, and then just public static void main, like always. Okay, and then we want a well, a method. We can call it getSum, like that. And then we have 2 parameters, one for x and one for y. Okay, there you go. So what we have now is one big difference. It's not saying void there. We have int instead. So void simply means that we're not returning anything from this method. If we replace it with any type at all, it could be any type that does exist that we can use for the variables or the parameters or anything. We can put that there instead, and all of a sudden we are required to return that types. So now if I hit compile, save it, it's going to give me an error, missing return statement. Why is it complaining? Well, I told it I was supposed to return an integer, but I'm not. So I have to return that, otherwise my code is not going to be compiled. There you go. So now what I'm doing here is calculating an integer here and then returning it. So I can return something from this method using return. And yes, this is the same return that I used to exit programs in earlier examples. We can go and take a look on that on the calculator here. I'm using return here, but without a value, and that's because the main method here has the type void. That means that we don't return anything from it at all. But even if your method is of the type void, we can, if we want to, return void, and that means that we just returns nothing, but we are exiting the method, and that's how I can exit a program. Because if I return, like stop this method in the main method, then I exit out of the program. So as you can see, the only reason why I can exit the program like this is because I'm in the main method, like so, and the only reason why it's the same is for the, well, it's for the same reason, but that's not what it usually is used for, because, well, when we do, where do I have that? there you go, return example. Here we use it to actually return a proper value, and we have to return a value. If we tell it that, well, we want to return an integer value, then we must return a value, otherwise it won't work. Okay, so now we can use that by doing, well, let's just do it like this. 10.4. Hit compile. So what we have here is getSum here. That's the method from down there, and we'll give it the two parameters, 10 as x and 4 as y. And when we do that, it's going to run this code here and then go back to where we called it from, like any other method. But since we're returning a value, it's going to use that value where we have the method call. So what we're going to do here is we're going to get that number. We're going to get 14, obviously 10 plus 4 equals 14, and then print it out, because it's the same as if we would type 14 there, because that's what we're going to return, and therefore that value is going to be used. So we hit compile and hit run, and it's going to print out 14. I can give you another example where you can do static string, so you can use any types, like I said, so we can use the string type instead, and we can tell it get reversed string. So I want to reverse the string here. Okay, so I'll give it one string as the parameter, and I want to reverse one back. So to do so, I can do reversed, and you can do this in a few different ways. I'm going to loop through it all backwards. So I'm going to loop through the string we give it from the back, from the end to the beginning, which we can do by starting at the end, loop while we are greater than or equals to 0 as the index, and then just decrease it by 1 each time. Like that. So then we just add that, but in the reverse order, and finally return the like that. We return the reverse string. So we give it a string, and then it's going to reverse it for us, and then we can use that. Okay, so let's use it. Let's even use it in here. So what do we all of a sudden have here? We have chained a lot of method calls together. So first of all, we calculate the sum of 10 and 4. Because we send 10 and 4 into the getSum method here and return an integer. That integer is concatenated with a string. Remember, if we if you use plus there between a string and an integer, it's going to assume you want to convert the integer to a string and then concatenate them. So it's going to be the sum is 14. Then we're going to send that string, sum is 14, to getReverseString method. That's method here. It's going to reverse it, so every character is in the opposite order, and then that's going to be returned and used in the printLine method. So yes, that's also a method. So we have chained 3 methods here together. We use getSum to get the string that we want to. We combine the sum is together with the result from that one, and then reverse it, and then we use that value to print it all out in the end. So now if I compile it and hit run, we're going to get 41 simus f. I don't know how to pronounce that. So if you read backwards, it says the sum is 14. So that's an example of how you can use return types. So you have the return type you want, but what you need to make sure of is that you'll always return a value, no matter what. If you have a void type, you can do return and then just a semicolon to make sure that the method ends, but you're not required to have a return just because you use void, which means we don't want to return anything. Okay, so that's that. Now we can go back to the valid integer example, and instead of printing it out, we might wanna return it. So I'm going to replace void there with int, and then we return the integer. Okay, so what we're doing here now is the exact same thing. We call this method here, we calculate the integer, but in the end, instead of just printing it out, we're going to return it, and then we can use it for whatever we want to in the end. Cool. But since that's the case, I can't use this. I could just print out the result I get, but I'm not going to do that. I'm going to remove that, and you'll see what I'll do. Okay. So now I'm going to improve this example. So what we'll do is actually ask the user for a year, a month, and a day. So we get a date, a valid date. We're going to check that it's actually a valid date in a specific range. Okay. So to do so, first of all, we want a year. And just for making things easier, I'm just going to allow you to enter, please enter a year, and that's from 1 to 2013. So it could be like which year was you, like which year were you born or something like that. It doesn't really make sense to have from 1 though, but it's just a range that we can easily change. It's just the range you want to be able to accept. And for this example, I decided to accept from today back to J1. And then we can. This is now very easily achieved because, well, we have something called next valid integer. It's going to give us a integer inside a specific range if we give it a scanner and a range, and it's not going to crash if the user enters something else like hello. Next valid integer, my scanner 1 2013. There you go. So we call that method, we give it a scanner because it asks for a scanner, we give it an integer because it asks for an integer, and we give it another integer because it asks for another integer, like so. And it's telling us that it's going to return an integer as well, and that's why we can store it inside our integer called year. Pretty straightforward. Okay, so now we have a year. Now we might want to ask for the month as well. Here we go. Please enter a month. 1 to 12. That's an easy one. You always have 12 in, well, not always, it depends on your calendar. But, well, we're going to have 12 months, int month, and then we do something similar. Next valid integer, and then we do my scanner 1 and 12, like that. Sweet. But now we get into some problem. Well, we get into some problems here because, well, how many days do we have in that specific month? How many days can we allow the user to enter? Can we allow the user to enter day 31? Can we allow it to enter day 30? So to check that, we will have to check for leap years and different months and things like that. And some of these things, well, most of these things, there are built-in functionalities for you to be able to use. But to use those, you will need some further knowledge. And this is simply just an example for methods. So therefore, I'm going to do it myself. I'm going to write the code for it. So first of all, we want to know how many days there are in a specific month, so we can ask the user for that. So I'm going to do like this. So I get the amount of days in a month. So that's something I'm going to have to add. So I haven't added that yet. But when we figure out that, then we can do please enter a day. Okay, and then we start from 1 to the days in the month. Like that. Oops, I need the other one there. There you go. So we start to print out that one, and then we just get the day itself. And that's pretty easy to do because we have that method, which is very nice to have. Get next valid integer, and I can't spell apparently. And to do so, we give it a scanner to read from. We start at 1, and then we have the maximum value of days in month. Okay, so that's pretty straightforward. Apart from one tiny little thing, we don't have a clue of how to calculate how many days there are in a specific month. So let's type that code, shall we? Okay. So there's one specific case, and that's if the month is the second month, February, and that it's a leap year. So we send along year as the first parameter to a method called isLeapYear. That method with that parameter, well, that method at all, doesn't really exist. So that's a problem, but we'll have to write it, but it's fine. Days in month equals 29. So if the month is the second, well, if it's the second month of a year in a leap year, then we know that we want 29 days in a specific month. So that's the special case, and if we don't have the special case, then we want a specific amount of days depending on just the month. Okay. So I'm just going to give it an array with the different lengths of all the months. Like that. I think that's correct. Yes, it is. So we have January, February, March, April, May, and so forth. So that's just the normal amount of days. So as you can see, we have 29 there because it's a leap year, but just 28 there because it's a common year. And then we do days in month equals days in each month, month minus 1. So the first month, January, that's month number 1, but in our array here, it's month number 0, because, well, in arrays, the first number has index 0, the second number has index 1, and so on and so forth. The last month here, December, has index 11, not index 12. So that's why I just subtracted by 1, like that. So now we get the correct amount of days stored in days in month, if it's a common year, not a leap year. But if it's a leap year and it's the second month, then it's February, then we can get 29 here. And the reason why I do it this way around, it's not really that important, but the reason why I check the month first and then the leap year is because, well, if we don't have February as the month, then there's no reason for us to call this method at all. And as you might remember, if we have an AND here and the first part of it is false, then there's no reason for us to check the second part, so that's not going to be checked. So therefore this method is not going to be called if there's no reason to. Okay, so let's create the isLeapYear thingy. The here we go, static boolean isLeapYear. So this is the method here, and I'm going to actually, as you are discussing now, actually in the Twitch chat, I'm actually going to do the proper way. I'm not going to do every 4th year is a leap year, because that's not the case. I'm going to do the proper one. It's quite simple though. It's quite simple algorithm, but it's also good because it's going to be a good example of return values. Okay, so first of all, if it's for every 400th year, there is a guaranteed leap year. Ooh, I missed that curly bracket. Come on, curly bracket. There we go. So therefore, we're going to return true. So it's a leap year every 400th year. Leap year. I forgot that. Come on, there you go. Year every 400th year. Okay. However, if we're not if the year is not every 400th one, then we'll have to check if it's every 100th one. Because if that's the case, then it's not a leap year. Turn false. No leap year every 100th year. So that means it's not a leap year, and we return false. And then we can check else if year mod 4 equals 0. So that's the normal check, the thing that you would normally think about when it's like, is it a leap year this year? Yeah, just divide it by 4 and see if it's evenly divisible by 4, like that. But yeah, as you can see, we have some more advanced things to get everything to sync up properly, and that's just how leap years are calculated. Normal leap year every 4th year. And then finally an else here we will return false. And let's just call this a common year. It's called the common year, but this is actually also a common year, so when we return false, it's actually also a common year. So as you can see now, to calculate if a year is a leap year, it has to be I'm not returning anything here, silly. It has to be every 4th year, that's for sure, but it's still not a leap year. For instance, year 1900 was not a leap year just because it's evenly you can divide it by 100 even amount of time, so it's year mod 100 is 0, so you can divide it properly there. So that's not a leap year, but year 2000 was a leap year, even though that was the case, yes, because it's also you can also divide it by 400 evenly. So that's just how you calculate leap years. And as you can see now, I'm having 4 different return statements, and that's totally fine. You can have as many as you want to, if you make sure that 2 things applies. First of all, you need to have a return statement in each code path. You remember, we always need to return a Boolean value because we tell it that we are going to do so, and therefore we can't just nothing there. It's fine. So even though we don't have to have one return statement that is always returning the value, we have to have a return statement that we always will reach. So we will always reach one of these guys because, well, we have an if else statement here, so we will always reach one of these return statements, so that's fine. The other thing we will make sure of is that we can actually reach all I misspelled that. Here we go, that we can reach all the return statements, and that goes for all the code. If we type some code right after a return statement, that code is never going to be run, and therefore we can't really have it there. So I can't like int a equals 2. I can't do that either. Yes, because, well, this code is never ever going to be reached. So if you keep those 2 things in mind, that all return statements can be reached, and that we will always reach one return statement, then you can have as many as you want to. So that's why we have 4 different ones here, like that. So now we can check if it's a leap year, so that's awesome. And yeah, now we can calculate how many days we have in that specific month. So let's run this code. So first of all, enter a year. I'm going to enter 2000. Please enter month. Let's go with February. And as you see, it's detecting that this is a leap year, and that's why I can enter a day from 1 to 29. If I enter something else like 30, it's not going to accept that. If I enter nothing, it's not going to accept that. If I enter something that's not a word at all, it's not going to accept that. If I, however, enter an integer there, it's going to accept that. However, it's not going to print anything else out on the screen, but that's fine. Let's fix that. Okay, so to print this on the screen, what I'm going to do is the following: system.out.println, like so, for print line, and selected date, add a year. Okay, so depending on like what your common way of typing out dates is, this might look weird or it might look perfectly fine, but I can't like satisfy everyone. So what I'm going to do is do year, then a dash, then a month, or then a dash, and then the day. So that's just how I'm going to print it out. I can't print it out in all different ways. You can of course write a program that asks you which way you wanted to print that out, but I don't have the time to do that now. We're running quite low on time. Okay, so we want to use a method called getLeadingZeros, but that doesn't exist, but that's fine. And then we add this other dash there, and then we finally do getLeadingZeros day, and then 2, like that. So what this getLeadingZeros are supposed to do is it's going to get a value, an integer value, and then it's going to make sure that it has the required length. So for instance, if it's the second month, then we don't want it to say 2, so dash 2 dash. It's supposed to be 02, so we always has the month using 2 digits. For instance, here's the way of making it look better. So now we can do that. So we do static string because we want it to return a string of this text here. and then we do get leading zeros, and then we give it first of all the value and second of all the length, like that. And to fix this now, we're going to have, I'm going to call it return value, which is equals to this. So we want to convert this integer here to a string. We could do so, like we've seen before, by just adding it together with a string, but we just want that single integer as a string. We don't want anything else, which we of course could achieve by concatenating with nothing, like that. But if you wanted to do it properly, you just do string dot value of and then the value there. You can do it in a few different ways as well. And as long as the length of the string that we just created is shorter than the length of the length we want, then we're just going to add a 0 in the front, and we do it like this. And finally, just return that return value. Okay, hit compile, and then we run it. There you go. So now I can do, please enter year. I'm going to enter year 500, and then please enter month. I'm going to enter the second month there, and it's not a leap year, even though it's well, it's one of these 100th year. It's not a leap year kind of years. And now if I type, for instance, 4, then it's going to say 500/02/04, just because we're making sure that we have a leading 0 there. But if I do it again and type, for instance, 2001 and then 11, so that's November, and then like 20, then it's not going to give me any zeros, so it's not going to say 011 or 020, because it's checking the length of that and making sure that all of those are correct. So I'm not going to have time actually to comment this code, but more than this, but yeah, it will have to do it. So we have made 3 different methods now. One quite handy called next valid integer, so very handy there. It makes sure that the integer that we get from the scanner is actually an integer, and it also makes sure that it's in a given range, and then we return that. And we have one for leap years and one for adding leading zeros, but like I said, I'm running out of time, so let's see what we've learned today. Okay, so first of all, we spoke about switch statements. We can do switch and then the value we want to switch on, and then we have different cases. We can end it with a default case as well, or put the default case somewhere else as well. Remember the break statements to make sure that we don't run multiple cases unless we actually want to do that. In this example, we have a my variable equals 1, and then therefore we're going to run the code after the case 1, and therefore we will print out value is 1. The break will make sure that we won't print out value something else as well. We can also do it like this. As you can see here, we have a switch of a character. The operator there is of character type, and then we have one case called x and one the multiplication type there. And since we don't have a break in x, we're going to run the code result equals number 1 times number 2, even though we had the operator as x. But if we have the operators as the star, we will still do the same thing. Then we had methods. We call a method by typing its name and then the empty parenthesis there. Or if we had parameters, which we will discuss in a tiny bit, the summary will talk about that in a bit, we added the values of the parameters we want to send along there. And then we have the method static void my method, empty parenthesis there, and inside there we can actually type whatever code we want. Here we go, parameters like I said. So in this instance here, we do my method 3, 2 because we want to send 3 as the first parameter, the first integer parameter, and 2 as the second one. So then when we access x and y in the code, it will have the values 3 and 2 in this specific instance. Next time here, we have a return type. So we have static string my method, and we return hello. and then we can use that value. We get the value up in the main where we just print out that return value. And remember, if we have a method that returns something, then we have to return a value of that type. We can't ignore that. Always, if you have a return type, return that value. If you have void, then it's fine, you don't have to return a value. You can still use return if you want to break out of that method. Then we of course have the question and exercises, like always. Questions to see if you have learned things, exercises to practice those things you've learned, further exploration to continue on, and then answers and possible solutions to questions and exercises. Something that is new is that all my examples that I have had during a lecture is also going to be uploaded to the lecture page, and this is not only the case for this specific lecture, but I've also uploaded the old examples from the previous lectures. So now we're out of time. Thank you all for watching. This has been Coding and a Cup of Java, lecture number 5, Switch Statements and Methods. I've been VSWE. Thanks for watching, and I hope to see you next time.